Okay, everybody, homework on law of cosines, page 330. I'm going to write law of cosines. So we're always going to have cosine when we're punching our calculator. Law of cosine, make sure you are in degrees. Make sure you're in degrees, everybody. See where it says degrees? Make sure you're in degrees. Okay, so on the first one, we're going to do 8, ACE, ace, so 8, A. It says A is 10, B is 11, and angle C is 45 degrees. And it says find little side C. So if you draw a triangle, which you don't have to, I'm just drawing it just because I feel like it. This is angle C. We'll say this is 45 degrees. That's angle C, big C. Little c is what we're trying to find. And then it doesn't matter where you put angle A and angle B. So side A is across from angle A, that's 10, and side B is 11. So these three things are what you know. This is called SAS, side included angle side. Since we're finding little c is equal to the sides, and it doesn't matter which side goes first, so I always do the smallest side, just for like some kind of routine. So 10 squared plus 11 squared minus 2 times 10 times 11 times cosine of the given angle, 45. And from here, you're just going to punch it straight into the calculator. So we're going to go square root of 10 squared plus 11 squared minus 2 times 10 times 11 times cosine of 45, which we should know that cosine of 45 is about 0.707 is what we're multiplying by. And when we press enter, we get 8.1. Okay, so 8.089 you could use if it says near 1,000. It doesn't say in the book what to do, so I'm just going to go nearest 10, 8.1. So side C is about 8.1, and that's your answer. Any questions? If you do, I'm not here to answer them, but hopefully you understood that. All right, C, 8C. So this time they're going to say that A is 15, B is 62, and C is 65, and find angle B. Now, when we ran out, now first of all, you guys can punch these numbers right into one of these formulas right here, but I gave you a derived formula. So let me just go over those in case you ran out and didn't get them. If you're solving for angle B, oops, cosine, you're right, cosine, that's a cosine. Cosine B, it's a fraction. The one that you subtract is the largest side because, well, just let's do it this way. It's not always the largest side, I guess. Just make sure if this is B, always subtract B squared over here. And then this is going to be A squared plus C squared. All three sides should be included on the top, but one of them is always subtracted. I always subtract the one across from the one I'm solving for. And then on the bottom, you have 2AC. So when you punch this in your calculator, you're going to get a decimal. And then you're going to take arc cosine of whatever all of this is. Okay? If you're trying to find angle C, you would subtract little c. And then this would be A squared and B squared. And this would be 2AB. And if you're trying to find angle A, you would subtract little a. B squared plus C squared, 2BC. These are the three derived formulas when you're given S, S, S. So these are three formulas that go along with the three that I gave you in the book yesterday. So make sure these are in your book somewhere. So we are using the first one. We're trying to find angle B. So I'm just going to show you the triangle. I just like drawing these. I don't know why. So this looks like my longest side, so I'll say this is 65. And we'll say this is 62, and this is 15. It doesn't, and again, it doesn't matter. But they want us to find angle B. So if this is C, this is angle C. B is 62, so this should be angle B. And this is 15, and this would be A. Make sure angle A, side A is across from angle A. make sure side B, which is 62, is across from big B. And make sure 65, which is C, is across from angle C. Hope you guys can't even see what I'm doing. Oh my gosh, sorry. Make sure 65, I'm sorry, which is side C, is across from angle C. 62, which is B, is across from angle B. And make sure 15, which is A, across. Okay. So anyway, I always do the largest angle first, but they're not asking us to do that. So this is my one-time exception not to find the largest angle first. If they tell you to find B, just find B. You don't have to find the largest angle first. Only if you have a choice, but they're not giving you a choice. They're saying find B. So to find B, you're going to say cosine B equals subtract side B. So if you're solving for B, subtract side B. I always usually subtract the largest side squared, but in this case, it's not the largest side because they're telling us to find B. So we're just going to go with this. All right, so the other two sides are 15 squared and 65 squared. And then over 2 times 15 times 65. The one that you're subtracting, you never use it again. You only use it one time. The other two, you should use twice in the formula. Now we're going to punch this in the calculator, but you have to be very careful. Whenever you have more than one number in top or bottom, you have to use these parentheses. These are your friends when you're doing a calculator. And let's just do this. So we need to do a parenthesis. So parenthesis. And we're going to go 15 squared plus 65 squared minus 62 squared. Parenthesis. So by putting the parentheses, you're getting that all to be one number. Then divided by parenthesis. And then you're going to do 2 times 15 times 65. Parenthesis. So this is what it looks like. Now when you press equals, you're going to get a decimal. Now if the decimal is positive, like it is, your answer is between 0 and 90 because cosine's positive in the first quadrant. If this is ever a negative decimal, it means your angle is obtuse. It means it's in the second quadrant because cosine's negative in the second quadrant. So as long as you get a positive decimal, your answer is between 0 and 90. Now this is not an angle. 0.3 is not an angle. I repeat, 0.3 is never going to be your angle. An angle is a little bit bigger than this. So to get this angle, we're going to press second cosine or arc cosine of 0.310769, all these decimals. So there's a couple ways to get this decimal in there. You could press second cosine like this, and you can highlight that decimal and press enter. See, I did that. And then press enter, or let me delete that, clear that. Or you can press second cosine, second negative, because above the negative sign down here, you see this negative sign? It has the word answer above it. That's your previous answer. So just press negative. So it's second sign. It'll say arc cosine of the previous answer, which is this. And if you press enter, it'll give you the same thing. So it's 71.9 degrees. 71.9 degrees. So angle B, right, angle B is 71.9 degrees. And that's your answer. Pretty easy, huh? 8E. So 8E, we got B is 50, C is 25, and angle A is 150. Find A. This is obtuse. This is what an obtuse one looks like. We're finding little A. B is 50, and C is 25. So we're labeled C. Make sure C is across from side C. We're finding A, and that's it. So to find A, we're going to take a big square root. We're going to go 50 squared plus 25 squared minus 2 times 50 times 25 times cosine of 150. Let's type that in. I want to clear everything out. So we have square root of 50 squared plus 25 squared minus 2 times 50 times 25 times cosine of 150. 72.7. And that is not an angle, so don't put degrees. 72.7 is a side. Angle B was, so angle B is a degree. Make sure you have degrees for angles, no degrees for sides. That's our first three. How are we doing? I'm turning my page. I'm actually going to switch pages. So number 9. What is the measure of the largest angle in a triangle with sides 3, 5, and 7? The largest angle. So let's just call this A, B, and C. It doesn't matter. Okay, so if you have a triangle, you have angle A, B, and C. We'll say A is 3, we'll say B is 5, we'll say C is 7. So what is the angle, measure of the largest angle? That largest angle has to be C because it's across from the largest side. Largest angle is across from the largest side. In this case, the smallest angle would be A because it's across from the smallest one. So we're solving for angle C. So how do you solve for angle C? Cosine of C is equal to, always subtract the largest side if you have a choice. Okay, we're going to solve for the largest angle, so we're going to subtract 7 squared. Then you have 3 squared and 5 squared. And then over 2 times 3 times 5. Parentheses, don't forget your parentheses. And then we're going to take arc cosine at the end. Arc cosine of all of this. So let's do it. Clear this out. We got parentheses. Sometimes I don't like to type in 3 squared, so I'll just do 9 because I'm lazy. I'll do 9 plus 25 minus 49. Just saves me time. Divided by parentheses. And then 2 times 3 times 5. You could do 2 times 3 times 5, or you could just do divided by 30. Anyway, you get a negative. Now, when you get a negative decimal, it means that you have an obtuse angle because, think about it, cosine's positive here but negative here. So your answer is between 90 and 180. That's obtuse angle. It's a big angle. So anytime you get a negative value, you have a big angle. Let's see how big it is. Well, we actually know what it is. What is, when's cosine 1/2? Isn't that 60? But it's not 60, is it? Because it's negative. It should be 120 if you guys are good with your unit circle. Let's verify that. Second cosine. We'll just highlight that. And you get 120. You should have known that from your unit circle. I think I'll put that on a non-calculator test. What do you guys think? 120 degrees, and we're going to call that angle C in my diagram. I don't think it was C in the book, but we made it our diagram. So it's 120 degrees, largest angle. Questions? Moving on. The next one, what is it? 10. Number 10's next. Number 10. Use the law of cosines to find the perimeter of a regular pentagon. Let's draw a pentagon. Regular means that all the sides are the same. So there's 2 sides, 3 sides, 4 sides, 5 sides. I just made a house. That's a regular pentagon. All 5 sides are the same. Well, if I measured, I don't think these are exactly the same, but they're supposed to be. They want the perimeter. That means they want you to add all 5 sides. And they said that it's, okay, the regular pentagon is inscribed in a circle. A radius 6. So the circle's on the outside. I should have drawn the circle first. I think I better draw a circle first. Let's draw a circle. And the pentagon is inscribed in the circle. Whoops, that's supposed to be straight. How about that? That's like a tent. All right. Use the law of cosines to find the perimeter of a regular pentagon inscribed in a circle with a radius of 6. This is 6. And this is 6. So basically they're all 6, right? We know all these are 6. All the radii is 6. I bet we can figure out what this angle is. So we have 5 interior angles, right? Does anyone know what this is? What's all the degrees in this? I just drew a circle, right? All of this is 360 degrees, but there's 1, 2, 3, 4, 5 angles. So 360 divided by 5 is, what is that, 108? Let me see. 360 divided by 5 is, oh God, I'm not even close. 72. It's late. That's terrible. I thought that was 108. 72. Anyway, each one of these is 72. 72. All of them. 72. 72. 72. 72. All these interior angles are 72. So let me just pull one of these triangles out so you can see it. What we have right now is an isosceles triangle with 6 and 6 and a 72 interior angle. So that is a side angle side, SAS. That's law of cosines, right? So we want to find, if we find this side right here, we should be able to get the perimeter because these should all be the same because it's regular. It's a regular pentagon. They're all 5 sides are the same. So if we can just figure out this side, times it by 5, and we'll have the perimeter. We can do that. So we're going to find this side right here. This side right here. So we do that by using law of cosines. So we have 6 squared plus 6 squared minus 2 times 6 times cosine of 72. Let's do this. Are we having fun yet? So we got, okay, I'm lazy. I'm going to do 36 plus 36. That's 6 squared and 6 squared. I'm just too lazy. Minus 2 times 6 times cosine of 72 equals. So 7.05. Let's just keep it 7.05 for now. So we have x is 7.05. So that's this. That's this side right there. So that means this is 7.05, and this is 7.05, and this is 7.05, and this is 7.05. And perimeter means add them all up. So instead of adding all them up, let's just multiply our previous answer by 5. So we're going to get 35.267 or 35.3. We'll say that the perimeter is 35.3. And this regular pentagon, it just said a radius of 6. It didn't say inches or anything, so I would just say 35.3 units, whether it's inches, feet, whatever, 35.3. Fun stuff. Next, 11. Okay, they give you a picture, 70 degrees, 15 feet, and 21 feet. And they ask you to find the perimeter of Terry's triangular garden, plot in the diagram below. So if we knew this side right here, we could just add the 3 sides. So far, my perimeter is 15 plus 21. So we know it's at least 36. 36 plus whatever x is. So we're going to use our law of cosine because this is SAS. SAS is, call this x. 21 squared plus 15 squared minus 2 times 21 times 15 times cosine of 70. Are you guys getting quick at this? I hope so. Oops, you can't see what I just said. 21 squared plus 15 squared minus 2 times 21 times 15 times cosine of 70. Let's put it in. Square root 21 squared plus 15 squared. Now the numbers are getting big. I better just put them in. Nothing in my head here. Times 21 times 15 times, last one, cosine of 70. Boom, 21.2. So x is 21.2, so I'm going to put that right here. And that's also feet. So we're going to put that over here. 36 plus 21.2 is, I can do this in my head, let's see, 57.2 feet. Because you're adding them all up. This is too darn easy. 12. 12. 2 fishing boats leave the harbor at 6 a.m. each, traveling in a straight line. The angle between their paths is 65. Okay, so we got one fishing boat coming here, about 65, maybe here. Fishing boat A, fishing boat B. And then the angle between them, they're leaving at 65 degrees at 6 a.m. The first boat averages 15 miles per hour. That's not a, so you know, that's not a distance. That's a speed. We'll figure out the distance here in a second. The second one boat is faster at 25 miles per hour. Okay, so it's going to go a little further, it looks like, because it's going to be going faster. Does it make sense? This one should be longer because it's faster. How far apart at A? How far apart are the 2 boats after 1 hour? And then after 2 hours? Well, after 1 hour, you would do 15 times 1 for 15 miles. In 1 hour, you would do 15 times 1. It's 15 miles per hour. So if the hour is 1, 15 times 1, that means the first boat traveled 15 miles. But the second boat traveled 25 miles per hour. So it'd be 25 times 1, which is 25 miles. And this is 65. And they want to know, how far apart are they? So that's right here. This is boat A, and this is boat B. How far apart are they? So it would be x equals 15 squared plus 25 squared minus 2 times 15 times 25 times cosine of 65. Do you see how everything, this calculator is pretty important in this section? You get 23.1. So they're about 23.1 miles apart after 1 hour. So I'm going to write after 1 hour. Now after 2 hours, what would it be? So remember, they're going 15 miles. The first boat's going 15 miles per hour. After 2 hours, that would be 30 miles. If you're going 15 miles per hour for 2 hours, this is a distance of 30 now, not 15 times 2. And then this boat was going 25 miles per hour times 2 hours, which would be, he will have traveled 50 miles. Remember, they started off 65 miles apart, so it's the same thing, except it's 30 squared plus 50 squared minus 2 times 30 times 50 times cosine of the same angle. So I'm going to be lazy here. Watch this. I'm going up to my previous one. Oh, gosh, how do I do this? I don't want to. Okay, I highlighted it and brought it back. So I want to keep the cosine of 65, but I want to change 15 and 25. This is the lazy way of doing it. I'm going to type this into 30. 50, 30, 50. Did I get them right? 30 and 50. And the cosine 65 is still the same. And that's 46.2. Guess what? Did we really have to do that work? Because this has just doubled the time. I'm not sure if we had to do that work. B. Without using the law of cosines, predict how far apart the boats would be after n hours if they maintain their respective speeds and directions. Explain your reasoning. I think that since this doubled after 2 hours, that it would be 23.1 n. So 2 hours we did this, 3 hours you just times it by 3, 4 hours. Explain my reasoning. The boats are traveling at a constant speed, so you have a constant speed. They're on cruise control, so the distance between the boats will change at a constant rate. Something like that, right? 13, last one. You cannot use the law of cosines if you know what? So A said 3 sides. It's this. And it says you cannot use the law of sines. Is that you can use the law of cosines. So this, it's not A. B, 2 sides and the included angle. You can use law of cosines for both of these. So these are not your answer. C, it said 2 angles and the included side. That's what that looks like. This one, we're actually going to be using the law of sines, and we're going to be using that next week. So it looks like the answer so far is C. And then D, it says 2 sides and a non-included, 2 sides and a non-included angle. This is also going to be law of sines. So it looks to me like there are 2 answers to this. I'm going to say it's C and D. You only use law of cosines if you know SSS and SAS. Done!